Happy day students. In today's class we are going to start our next new chapter, complex numbers and quadratic equations. What is called as complex numbers? So far we were learning about real number system, right? So we know our number system till real numbers only. We started with whole numbers, natural numbers, then integers, rational numbers. Then we learned what is irrational numbers, and all these form a real number system. Now we are going to learn what is meant by complex numbers. Where this complex number will play a role. Whenever you come across a square root of a negative number, see for example x square equals to -1. Immediately what we will say, when we have square root of a negative number, x is equals to square root of -1. is not possible. The answer is not a real number. We stopped with that till last year, right? So now after learning complex numbers, you can find the square root of a negative number, because -1 is defined as I square. -1 is defined as I square. So the numbers involving this I is called as complex number. I repeat, my square is defined as -1. Wherever you have -1, we can replace it by I square. And the numbers involving this I is called a complex number. Therefore, what will happen to the square root of -1 now? Square root of -1 is nothing but square root of I square. Square root of I square is I. That's it, right? So we can express that particular number in terms of I. Then it will become a complex number, not a real number. Yes, in general we will express a complex number is of the form a plus ib. Any number of the form a plus ib, where a and b are real numbers. This a and b are real numbers is defined to be a complex number. Few examples of complex numbers are given. 2 plus I3, where 2 and 3 are real numbers, but it involves a complex number I here. Therefore, it becomes a complex number, right? For the complex, normally we will denote the complex number by Z. Z equal to A plus IB. A is called the real part, denoted by RE of Z, and B is called the imaginary part, and it is denoted by IM of Z. Okay, for example, if we have Z equals to 2 plus I5, then 2 is called the real part of Z and 5 is called the imaginary part of Z. The number involving with I is called the imaginary part, right? Complex number have two parts, real part and the imaginary part. Real part we denote by RE of Z, and imaginary part we will denote it by IM of Z. What is Z? The entire complex number we will denote it by Z, right? Hope you understood now what is meant by complex numbers. What is meant by complex number? A number of the form a plus ib. Any number involving this I is called a complex number. What is this I? I doesn't have any value. I square is only -1. I square is -1. Right, where a and b are real numbers. So what we learnt now, any complex number is denoted by Z. Z is a plus ib, where the value of I square is -1. Every complex number will have two parts, real part and the imaginary part. Real part we will denote it by RE of Z. Imaginary part we will denote it by IM of Z. RE of Z is A, IM of Z is B. Now what are we going to do? We are going to define algebra of complex numbers. See, what is meant by algebra? All the four arithmetic operations, addition, multiplication, division, subtraction, we are going to define for complex numbers. And we have seen all the properties, right? Closure, commutative, associative, identity, existence of identity inverse. Everything we are going to check for complex numbers. That is what we will do when we are introducing a number system, right? When we learned integers, what we did, we checked all these properties for integers. Then we started learning rational numbers, we checked all these properties. So the same way, now after defining complex numbers, we are going to check all these properties for complex numbers. It's just an extension. right? So first let us see what will happen to the addition of two complex numbers. So z1 and z2 are two complex numbers. So a plus ib, z2 is denoted as c plus id, be any two complex numbers, then their sum z1 plus z2. How will you add two complex numbers? While adding two complex numbers, you should add the real parts together plus I into the imaginary parts together. So a plus c, what you are getting you should write first, plus b plus d, what you are getting you should write along with I. Right? Hope you understood. This how only you have to add two complex numbers. Now let us check the properties. Closure law. What is meant by closure law? The sum of two complex numbers will give a complex number or not. If it gives a complex number, then we will say it is closed under addition. So sum of two complex numbers is a complex number. If you add two complex numbers, again you are going to get the answer in terms of I only. Therefore it is going to be a complex number again. Therefore it is closed. What about commutative law? They are telling for if you add any two complex numbers, the answer does not change even if you change the order. Z1 plus Z2 is going to be same as Z2 plus Z1 under addition. Similarly, when the commutative law is true, associative law also becomes true because it deals with three complex numbers, just the extension. Then what will be the additive identity here? 0 obviously when we talk about addition. Because 0 can be expressed as a complex number by 0 plus ib. Complex number now what we need? We need a real part plus I into the imaginary part. 0 can be written as 0 plus I0. Automatically it is going to become 0. But we have expressed it in the form of a plus ib. Therefore it has become a complex number. Right? So z plus 0 will become z. Then what about inverse? When we are talking about addition, which will be the inverse? The negative of that particular number is going to be inverse. So if a plus ib is one complex number, what will be its additive inverse? Minus z. Minus z means minus a minus ib. Alright, if you add those two, you will get 0. These are all we learnt already in our previous classes for all other number systems. Now we are just extending those concepts to complex numbers as well. Right? First we have seen how to add two complex numbers. How will you add? Whatever multiplication or addition or subtraction, whatever arithmetic operation are you going to perform between two complex numbers, how will you perform? It should be between two real parts and between two imaginary parts. Right? So hope you understood. Let us see what will happen to the difference of two complex numbers. In the same way, z1 minus z2 means what you should do? You should subtract the real parts and then you should subtract the imaginary parts. This is like doing addition or subtraction between the like terms, right? When numbers involving I only will become like terms, we will add those two. That's why it is called as algebra of complex numbers. Alright, then we checked all the remaining properties we can check, but it is not given in the textbook. We know few properties will not be true for difference of subtraction curve, few properties won't be true. Right, commutative and all, it won't become true for a difference of two complex numbers. Then let us move on to multiplication of two complex numbers. The multiplication, how will you do? Z1 into Z2 means you have to multiply term by term. You have to multiply term by term. A into C plus A into ID plus IB into C plus IB into ID. When you have IB into ID, I into I, it will become I squared. So that term will become minus. Right? So when we solve problems, it will be easy for you. It will be more clear. Right, now the remaining properties are also checked here. Closure, commutative, associative, all these properties are also true. When it comes to multiplicative identity, we know it is going to be 1. How will you express 1 as in the form of complex number? 1 and there is only real part. There is no imaginary part. So imaginary part can be expressed as 0i. Right? So from this it is very clear every real number is also a complex number. Every real number can be expressed as real part plus 0 imaginary part. So it will become a complex number. So after real number system, what do we have? The biggest number system is complex number system only. Right? Real number system lies in the complex number system. Complex number system is the biggest number system because every real number can be expressed in the form of complex number. Right? What about multiplicative inverse? Multiplicative inverse is 1 by z. What is meant by 1 by z? 1 by z means 1 by a plus ib. So how can you make this 1 by a plus ib? We have to multiply by its conjugate. Right? That I will teach you how to do this. Then is your distributive law. Distributive law we know z1 into z2 plus z3 is z1 z2 plus z1 z3. The distributive law is also true. Then what about division of two complex numbers? Z1 by Z2. Only if you know what is 1 by Z1, how to find the reciprocal of a complex number, we can proceed with the division of two complex numbers. So let me teach you how to find the reciprocal of a complex number. Now let us learn the algebra of complex numbers. What we learned theoretically, now I will show you with the example. Now let Z1, one complex number we have taken it as 2 plus I3. The another complex number is minus 6 plus I5. Now let us see what happens or how to add two complex numbers. So 2 plus I3 plus minus 6 plus I5. So as I told you, you should add the real part and the imaginary part. So 2 minus 6 plus I is common, right? So 3 plus 5. I is common in these two terms. So this is going to be minus 4 plus I8. Minus 4 plus I8 is Z1 plus Z2. This is how only you should add two complex numbers. Now let us see how we can subtract two complex numbers. Z1 minus Z2, which is equals to Z1 is 2 plus I3 minus Z2 is minus 6 plus I5. So to avoid confusion with the sign, first remove the bracket. Since it is plus, we have done directly. If it is minus, first remove the brackets. 2 plus I3, minus into minus it will become plus 6. Minus into plus it will become minus I5. Now club the real part and the imaginary part. So 2 plus 6 is 8 plus I is common. So 3 minus 5. This is minus 5. So it is nothing but 8 plus I into minus 2. So this is nothing but 8 minus I2. Right? So this is your difference of two complex numbers. Right? And one more thing is, normally we will write the numbers after, not after I. Numbers will be written first, then only I. So it can be written as 8 minus 2I. Right? Here also this can be written as minus 4 plus 8I. Right? This is the general form of expressing a complex number. Now let us see how can we multiply the same two complex numbers. Now how will you multiply Z1 and Z2? Term by term. 2 into minus 6. 2 6 are 12 minus 12. 2 into 5I. So plus 5 2s are 10I. Plus into minus is minus. 6 3s are 18I. Plus into plus is plus. 5 3s are 15. I into I is I square. This is very important. What is I square? Minus 1. So this will become minus 12. 10I minus 18I you can add. This will become minus 8I. So plus 15 into I square is minus 1. So this will become minus 12, minus 8I, minus 15. Again these two can be added. So both have minus sign. So you have to add and put negative sign. It will become minus 27 minus 8I is the product of two given complex numbers. Right? Hope you understood. Now let us see how can we divide two complex numbers. So before dividing two complex numbers, let me teach you how you can find the reciprocal of a complex number. 1 by Z1. What is 1 by Z1? 1 by 2 plus 3I. Now how will you find this? When you have a complex number in the denominator, you have to multiply and divide by its conjugate. Which is called its conjugate? The real part sign will remain same and only you should change the sign of the imaginary part. So what am I going to do now? I am going to multiply and divide by its conjugate. Which is its conjugate? 2 minus 3i. So I am going to divide and multiply 2 minus 3i. When we multiply and divide by the same number, the value is not going to change, right? So we can do this operation here. Suppose if your real part is negative, it should be negative only when you are multiplying. Only the imaginary parts you should change. That is called its what? Conjugate. This is called a conjugate of 2 plus 3i. Now what will happen? Numerator 1 into 2 minus 3i is going to be 1 minus 2 minus 3i only. But if you check out the denominator, it is a plus b into a minus b identity. Right? It can be extended for complex numbers as well. So it will become a square minus b square. So 2 square minus b square is 3i the whole square. Right? So this is 2 minus 3i divided by 2 square is 4. What will happen to the 3i square? See, 3i into 3i. So 3 3s are 9. I into I is going to be I square. What is I square? Minus 1. So 9i square is nothing but minus 9. Right? Already we have minus here. So minus into minus it will become plus 9. So 2 minus 3i divided by 9 plus 4 is 13. Is going to be the reciprocal of the given complex number. How can we write this in the form of complex number now? This 13 is common for both 2 and 3, both real part and the imaginary part. So this can be also rewritten as 2 by 13 minus 3 by 13i. So what is the real part of this complex number? 2 by 13. What is the imaginary part of this complex number? Minus 3 by 13. Along with the sign only you should take. Right? Hope you understood how to find the reciprocal. Just we need to multiply and divide by its conjugate. Conjugate means only the imaginary part sign should change. Now let us see how we can divide two complex numbers. Now z1 divided by z2. What is our z1? 2 plus 3i divided by what is our z2? Minus 6 plus 5i. Minus 6 plus 5i. So if we have a complex number in the denominator, we were unable to solve it, right? So what you should do? You should multiply and divide by the conjugate of the denominator. What is the conjugate of the denominator? I told you if the real part is going to be negative also, it should be retained as negative only. Only the sign of the imaginary part you should change. So this will become minus 6 minus 5i divided by minus 6 minus 5i. Right? So why are we doing like this? Then only in the denominator we can apply a plus b into a minus b identity, so that it will become a real number. A square plus b square you will get. Actually the identity is a square minus b square, but since we are dealing with the I square here, it will become minus. So minus into minus it will become plus. So when you do more problems you will get familiarized with that. Now let us multiply this. Now numerator should be multiplied term by term only. So 2 into minus 6 is minus 12. 2 into minus 5i is minus 10i. 5 2s are 10, right? Then 3 into minus 6 is minus 6 3s are 18i. Then 3i into 5i, plus into minus is minus, 5 3s are 15i square divided by, this is going to be a plus b into a minus b. See, a is minus 6, see minus 6, b is 5i. So a square minus b square, minus 6 the whole square minus 5i the whole square. So what will happen to the numerator now? Minus 12 minus 10 minus 18. So you have to add. So this will become minus 28i. While adding, I won't become I square. Don't do that mistake. This is like terms. 10x, 18x. What we will do? X will remain x only. So minus 15, I square is going to be minus 1 divided by The minus 6, if you square it, it is going to become plus 6 6 are 36 minus 5 5s are 25. I square is going to be minus 1. So it will become minus 25. Right? Hope you people are following me. So what will happen now to this? Which is equals to minus 12 minus 28i minus 15 into minus 1. So it will become plus 15, the whole divided by 36 plus 25. Right? So this is nothing but you have to add the real part. So 15 minus 12 is 3 minus 28i divided by, add these two numbers. So it is going to be 11 balance 1 4 5 6 61. So it can be written as 3 by 61 minus 28 by 61i. So this is Z1 divided by Z2. This how only you have to divide two complex numbers. Right? Hope you understood. So far what we learnt what is meant by a complex number. I square, the value of I square is minus 1. Then we have seen how to add, subtract. Addition, subtraction are like mere algebra. Real parts you have to add, imaginary parts you have to add and put I. And when it comes to multiplication, you have to do it term by term. And when it comes to division, you have to multiply and divide by its conjugate. When you are writing its conjugate, be careful. The sign should be changed only for the imaginary part, not for the real part. Right? Hope you understood. Now let us see the next topic. Next, what are we going to learn? We are going to learn about power of I. What will happen if we increase the powers of I? What is I? I means I power 1. I power 1 will be I only. Right? What is I square? I square is minus 1. What is I cube? This is defined. I square is minus 1 is defined. So wherever you come across I square, it is going to be minus 1 only. What is I cube? I cube can be written as I square into I, right? I cube means what? 3 times you need to multiply I. What is I square? Minus 1 into I. So this is going to be minus I. So wherever you come across the powers of I, you try to express it or break it in terms of I square, because you know the value of I square only. Right? When it comes to I power 4, how can you write it? You can write it as I square into I square. So it will become minus 1 into minus 1. So it is plus 1. Right? Likewise, we can find the powers of I. Hope you understood. If it is going to be I power 5, what will happen? This is I square into I square into I. Or else this can be written as I square the whole square. I square the whole square into I, which is minus 1 the whole square into I. So it is going to be plus I only. Yes. So hope you understood. And one more thing you can notice here, if it is going to be even powers, I square the, when you are able to write it as the square of I square, then it is going to be 1 plus 1. Or else if you find it difficult, you can do it in a rough column and apply your values there. Now let us see what will happen to the negative powers of I. What is I power minus 1? I power minus 1 is 1 by I. We know how to solve a complex number, right? What we will do? We will multiply it with this conjugate. Right? So here no need of minus sign, because it is simply going to be I. If it is going to be I itself, it will become I square. Right? So multiply and divide by I. Numerator will become I. Denominator is I square, which is I by minus 1, which is nothing but minus I. Yes. Hope you understood. Now what is I power minus 2? The same way, 1 by I square. 1 by I square is 1 by minus 1, which is minus 1. But what will happen if it is going to be minus 3? 1 by I cube. Right? 1 by I cube can be written as 1 by I square into I, which is nothing but 1 by minus I. From where I got this minus? Because I square is minus 1. Minus 1 into I is minus I. Now multiply and divide by I. So what will happen to this? Numerator is I, denominator is minus I square. So I divided by I square is minus 1. Minus 1 into minus is plus 1. So which is nothing but simply I. So this how only you have to derive the values of power of I. Whether it is going to be positive or negative. This how only you should proceed. Right? Hope you understood. Now what are you going to learn is square root of a negative real number. So far when we have a negative sign inside the square root, what we will do? We will say it is not a real number and we will stop it there. But now, from now, we can solve it. If we get a negative number inside the square root, we can very well solve it. We can express it as a complex number. Let us see what is square root of minus 3. When we have square root of minus 3, this can be written as I square into 3. Why? Because minus root 3 can be written as minus 1 into 3. Minus 1 is I square. So this is nothing but if you take square root for I square, this is going to be I. So I root 3. So minus root 3, square root of minus root 3 is nothing but I root 3. Right? Hope you understood how to find the negative of a square root. Square root of a negative number. Sorry, I mean negative square root of a negative number. Suppose if you have minus 64. What is this? Minus 64, I can write it as minus 1 into 64. That is 64 I square. What is the square root of 64? 8. I square is I. So this is nothing but 8I. So square root of minus 64 is nothing but 8I. Now let us see. Hope you understood how to find the square root of a negative real number. Now let us see the standard identities which we learnt in algebra. We are going to extend it for complex numbers as well. So now let us see the identities which we can use for complex numbers. These are all well known identities which we use in our algebra. What is first one? A plus b the whole square. What is a plus b the whole square? A square plus b square plus 2ab, which is true for complex numbers as well. So z1 plus z2 the whole square is z1 square plus z2 square plus 2 z1 z2. Similarly, the remaining identity is also true for complex numbers, which can be proved by using your distributive and commutative law. This is a minus b the whole square, this is a minus b the whole cube, and this is a square minus b square. Now let us solve exercise 5.1 using the knowledge of these identities and the basic I square equals to minus 1 concept and the power of I. We will solve the next exercise. The first question is express each of the complex number in the form of a plus ib. So they have given you a product or sum or a difference of two complex numbers. They asked you to express in the form of a plus ib. Already we know, I taught you how to add two complex numbers, how to subtract two complex numbers, how to multiply and divide, right? So it's just we apply all those concepts here and we will see how can we get our answer in the form of a plus ib. Now how will you do this? It's mere multiplication and we have only one term here. Only the imaginary parts are there in both the complex numbers. So multiply, this will become minus 3 by 5 into 5 into I will become I square. So 5 will get cancelled. This is minus 3 into I square value is minus 1. So plus into minus into minus is plus. So 3 ones are 3. So we got the answer as 3. But they asked you to express in the form of a plus ib. So what can we do here? We have only real part. So 3 plus 0i. Right? Thus we expressed it in the form of a plus ib, where a value is 3 and b value is 0. As I told you, every real number is a complex number. If this is your real number system and this is your complex number system, every real number is a complex number. This is z equal to a plus ib form. Here we will have simply a, b, c like real numbers. Every real number can be expressed in the form of a plus ib by replacing b with 0. Yes, Hope you understood. Let us see the next question now. Now let us see how can we solve this I power 9 plus I power 19. So try to express I in powers of 2, right? So I power 9 we can write it as I power 8 into I, right? Anyhow 8 plus 1 is going to be 9. If we have the same base we can add the powers. Similarly here I power 18 into I we can write. So 18 plus 1 it will become 19. Why we expressed as 8 and 18? Because it can be expressed as powers of 2 because those are multiples of 2, right? So this I power 8 I can write it as I square the whole power 4. Am I right? So that 4 2s are 8 I will get. This is basic exponents law of exponents. A power m the whole power n is a power mn. We will be multiplying. So 4 2s are 8 into I plus similarly I power 18 can be written as I square the whole power 9. So 9 2s are 18. Hope you understood now why we have written in terms of 2 powers 8 and 18, right? Now take I as common. Now why are we writing now in terms of I square? Because we know the value of I square. So this can be written as minus 1 the whole power 4 plus minus 1 the whole power 9. So this is nothing but I into minus 1 power 4 even power, minus 1 into minus 1 into minus 1 into minus 1, it is going to be plus 1. When it is odd power you will end up with minus 1 only. Yes, 9 times if you multiply minus 1 you will end up with minus. So plus 1 minus 1 0. 0 into I is going to be 0 only. So expressing 0 in the form of A plus IB is 0 plus I0 only. So it is enough if you write just 0. Yes, if you were unable to express in powers and all, no problem. You can easily find out as I told you. I power 8, how will you write? I square into I square 2, 4, 5, 6, then 8, right? And I power 9 means one more I we will get. Sorry, I power 9 only we need in the question, right? So how can you write I power 9? I square into I square into I square into I square into I. Then only 2, 4, 5, 6, 7, 8, 9 we will get. So that's what we have written. I square 4 times we multiplied. So I square the whole power 4 into I. Or else from this step you can directly substitute the values. This is minus 1 into minus 1 into minus 1 into minus 1 into I. So minus 1 into minus 1 is plus 1. Again minus 1 into minus 1 is plus 1. 1 into I is going to be I. Yes, hope you understood. So the same way you can do it for I power 19. Now let us see next problem now. Now how will you solve this? Using the identity. We don't have direct identity for whole power 4, right? So this can be written as 1 minus I the whole square, the whole square. Then only we will get whole power 4. First apply A minus B the whole square identity. A square plus B square minus 2AB. The same identity is true for complex numbers as well. The whole square is there, which is equals to 1. I square is minus 1 minus 2 into I is 2I. So this is whole square is there, don't forget. 1 minus 1 will become 0. So minus 2I the whole square. So which is nothing but minus, if you square it, it will become plus 2 square is 4I square. I square is minus 1. So 4 into minus 1 which is minus 4. But they asked you to express in the form of A plus IB. A only we have, we don't have B. So minus 4 plus I into 0. Thus we expressed the given question in the form of A plus IB. Right? Now let us solve the next question. Minus 2 minus 1 by 3I the whole cube. Right? So this is of which identity? A minus B the whole cube. What is A minus B the whole cube? A cube minus B cube minus 3AB into A minus B, or else A cube minus B cube minus 3A square B plus 3A B square. This is what our identity. This is true for complex numbers as well. What is our A here? Minus 2. What is our B? 1 by 3i. Kindly remember, we are using A minus B the whole cube identity. So this is our A and this is our B. Again, you should not take the value of B as minus 1 by 3. Always you should compare the question with your identity. If you have the same sign, you should take the values without sign. If you have different sign only, you should take the values along with the sign. So here the value of A is going to be minus 2 and the value of B is going to be 1 by 3i. Minus is same with the identity. Right? So you just substitute. So this is equal to A cubed minus 2 the whole cube minus B cube 1 by 3i the whole cube minus 3 into A square B 1 by 3i plus 3A B square 1 by 3i the whole square. Now if you expand, minus if you cube it, you will get minus 2 cube is 8 minus 1 by 3 if you cube it, 3 3s are 9, 9 3s are 27 I cube. Right? Then this 3 and this 3 we can cancel it. Right? Minus if you square it, it will become plus. So this minus we have. 2 square is going to be 4. I is in the numerator only. 1 by 3i. So 4i. Hope you understood. Then this will become minus 3 2s are 6. This 3 and this 3 I cannot cancel because whole square is there. This is not just 3. This will become 9. So you have to be careful while doing your calculation. So this will become I square by 3 3s are 9. Right? So this is what we got in the last step. Right? Now minus 8 minus 1 by 27. I cube is nothing but minus I. How? I cube can be written as I square into I. I square is minus 1. So minus 1 into I is minus I. Minus 4i. This 6 and 9 I cancelled using 3 tables. So 2 by 3. I square is minus 1. Now near calculations, add the real numbers and the complex numbers. Minus 8 plus 2 by 3 plus 1 by 27i minus 4i. Take LCM and simplify it. We got the answer in the form of A plus IB. So whenever a question is given and if they ask you to express in the form of A plus IB, just expand it if any identity can be applied, or addition, multiplication, you just perform your addition and multiplication or division or subtraction of the two complex numbers and try to obtain your answers. And I explained you already how to multiply two complex numbers, how to add, subtract and find the inverse of two complex numbers. Right? So with this, let us wind up today's class. Do these problems as homework and post it in the group. If you have any doubts, you can ask me. Thank you, students.